Welcome learners for the lecture 12 of a differential geometry. Let us go started as the helicoid. We consider surface obtained only by the rotation about the axis in its plane, and such sphere come into the anchor ring as well as a cone. But there are surfaces which are generated not only by the rotation along but the rotation followed by the translation. Such a motion is called as a screw motion. This screw motion is generated to the form that is a simple form of the rotation about the z-axis and translation in the positive direction of a z-axis. Usually we take the angle v through which is the positive axis rotated, it's proportional to the distance y, not considering y it is a lambda in this upward direction, and so that lambda by v is a constant. So the surface generated by the screw motion of the x-axis and the z-axis is called as a right helicoids. Okay, x-axis to the z-axis is considering as a right helicoid, so that we have to derive the equation of the right helicoids before taking in the general case. Representation of the right helicoid. This is a helicoid generated by the straight line which meets the axis at the right angle. If we take the axis of the generating line, it's rotate about the z-axis and move upward. Let O dash P be the translated position of the x-axis after rotation of the angle V will be generated in this form. Let xyz be the coordinate of the point P. Draw PM is perpendicular to the XOY plane and let OM equals to U. Then x equals to U cos V, y equals to U sin V, and z equals to PM. By assumptions, the distance PM equals to Z translated by the x-axis is proportional to the angle V of a rotation. Taking the constant of a proportionality to be the A, let Z by V equals to A in this form. And the position vector of any point on the right helicoids is considering to the form R equals to U cos V, U sin V, and AV. R1 equals to cos V, sin V, and 0, and R2 equals to minus U sin V, U cos V, A will be generated to the form. Since R1 dot R2 equals to 0, the parametric curves are R. When U equals to constant C, then the equation of the helicoids become considering R equals to C cos V, C sin V, and AV, which are a circular helicoids helices on the sphere. The parametric curve V are a constant in the generating of the constant distance from the XOY plane. Then R equals to U cos V, U sin V, and AV. R1 generated and R2 generated to the form cos V, sin V, and 0 minus U sin V, cos V are the distance will be generated. Further to the normal given as a condition, R1 cross R2 equals to A sin V minus A cos V U, and H equals to square root of A square plus U square. Hence, the unit normal capital N equals to 1 upon square root of A square plus U square, A sin V minus A cos V, and U will be generated to the form. Then definition will be considering as the helicoids for the representation to the form. If V equals to 2 pi, then 2 pi A is the distance translated after, because A is containing as a one complete rotation about the helicoids for the containing as a ring or the sphere. This is called as a pitch of a helicoid. Representation of a general helicoids. The general helicoids with the z-axis. The axis is generated by the curve of an intersection of the surface with any plane containing as a z-axis. Since the section of the surface by the such plane are the congruent curve, without of the loss of a generality, we can take to the plane XOZ plane and generate it to the helicoid. Thus, the equation of the generating curve in the XOZ plane can be taken as a form that is x equals to gu, y equals to 0, and z equals to f of u. Let the curve in this form XOZ plane rotate about to the z axis of the angle generating to the form v. Let it will be given to the translated in the proportional form of the axis. Since any point on the generating curve traces a circle with a center of a z-axis and the radius gu is considering an a z coordinate translated through the AV angle in the position of the vector of any point. Hence, on the general helicoids will be formed. Then R equals to gu cos V, gu sin V, f of u plus AV will be generated. Now R1 equals to g dash u cos V, g dash u sin V, and f dash u considering. R2 generated as a minus gu sin V, gu cos V, and A will be considering to the form r1 dot r2 equals to f dash u. A will be considering, hence the parametric curve are the orthogonal. Then there are f dash u equals to 0 or a equals to 0. If f dash u equals to 0, f of u is a constant, so that the surface is a right helicoid. If a equals to 0, considering to the form, do not ascribe to the motion, only to the rotation of the form in the helicoids in the surface of a rotation. When v equals to constant, the parametric curve are the various position of a generating curve on the plane of a rotation. When u equals to constant, it follow from the equation of a helicoid. The parametric curve are the helices on the surface of this form.